we're looking at the following limit as x goes to 2 from the left-hand side of the rational expression 2x squared minus 5x plus 1 over x squared plus x minus 6. So in order to simplify this a little more, let's go ahead and see if we can't factor this. Okay, well, let's see here. The numerator cannot be factored. Okay, you can go ahead and check, but this is one where we'll find that it's actually the situation where we have a prime. It cannot be factored. The denominator, however, can be factored, and we're going to make use of that, being able to factor that to help simplify this limit problem. So let's go ahead and take a look here. We have the limit as x goes to 2 from the left-hand side of 2x squared minus 5x plus 1 over, and factoring the bottom is actually real simple, x minus 2 and x plus 3. So you can use whatever factoring technique you'd like, but you do need to factor this. Okay, so be sure that you have factored. Figure out how to factor. I have several other videos on factoring if you're still having trouble with that. Alright, but now that we've done that, what I'm going to do is I'm going to do a little bit of separation here. I'm going to take this right here in isolation, and I'm going to group this right here together, and you're going to see what I'm going to do next. So what I'm going to do is I'm going to write out two separate limits, and I'm going to multiply them. The limit as x goes to 2, again from the left hand side, of 1 over x minus 2 times the limit as x goes to 2 from the left of 2x squared minus 5x plus 1 over x plus 3. Okay, so what we're going to do now is we're going to plug in 2, but in this case right here, and I'm going to block this off. Okay, in this case we're looking as we go to 2 from the left hand side. So let's take a look at perhaps a small range of numbers here. So let's pick some range of numbers, and let me draw a number line here. Well, here's my number 2. If we're coming in from the left, suppose that we have a number here, maybe 1.9. Well, plugging in this 1.9 right into this area here, we have 1 over 1.9 minus 2. And obviously, that's going to give us a negative number. Okay? That's going to give us a negative number. And notice that it's going to come very close to 0, so we're going to say that this is going to approach infinity. But since we have a negative number, this right here will actually go towards negative infinity. Okay, so that's going to approach negative infinity there. Alright, so we have negative infinity right here. Now when we plug in 2 up here on the next limit, as x approaches 2, let's just plug in 2 in general. Well, we're going to have, let's see here, 2 times 2 squared minus 5 times 2 plus 1 over 2 plus 3. Alright, so doing the order of operations here, we get, and I'm going to carry over the infinity, we get 2 squared, which is 4, and 2 times 4 is 8, okay, and then 5 times 2 is 10, so 8 minus 10, there is negative 2, and negative 2 plus 1 is negative 1, and in the denominator we have 2 plus 3, which is 5. So this fraction right here evaluates to negative 1 over 5. Well, we're multiplying infinity by a fraction. It really doesn't matter because we still have infinity. What does matter, however, is the fact that we have a negative times a negative. And anytime we have a negative times a negative, we end up with a positive. So this answer actually ends up approaching positive infinity. Okay, so this is something important to look at. what would have happened was that we could have initially plugged in 2, but we would have found that we would have had 0 in the denominator. So what we're doing here is a bit of a factoring technique to determine, well, we know it's going to go towards infinity, but is it going towards positive or negative infinity? And this technique is what helps us figure out how to approach this kind of a problem.
Made with Doodlecast Pro.